In section 3-4 today, we're going to jump back into our economics and our business models and how calculus and the business world kind of come together. And in this section, we're going to talk a little marginal economics. So what does marginal mean? Well, we'll define that here in a little bit. What I first want to talk about is, if I'm a producer, and you see the question there, when do I stop making an item? And of course, that's when I would give that to the class, and we would come up hopefully with the idea that when the cost outweighs the revenue, or the cost is higher than the revenue that we're bringing in, which is very true. You know, we don't want to be producing or making things that's going to cost us money. We want to make money using making those items. So that's really what we're going to be looking at today. When do we stop making an item, or when does the cost become more than what we want to have? So marginal definition is basically what we're looking for is how much is it going to be to make one more. So we can talk about the cost to make one more, we can make the revenue of selling one more, or we can look at the profit of producing or selling one more item. And we're always interested in, well, what happens if I sell one more thing? Is my cost going to start going up versus my revenue going down? Or is my cost still going down and my revenue coming up? And we'll be able to examine that through beginning today and ending in a few days from now. So the first thing we want to do here in example 1, we're going to give you a cost function. Here it's a kind of a nasty cost function. So we have the 0.001 x to the third, which is 1/1000ths, no, 10,000s, 1/10,000ths of x to the third, minus 800ths x squared, plus 40x plus 5,000. So is the cost the same for each of our items? So if I produced one item, would that be the same cost as producing 100 items? And we should see that within our cost function, our variables, we have x to the third, x squared, and x. So our variables are going to make this change quite quickly between 1 unit and 100 units. So that's why we know that the cost is not going to be the same for each unit. And that should hopefully make sense to you. If we produce one item versus producing maybe 1,000 items, we have a lot of different things that are going to happen between one item and 1,000. We may have to add employees. We may have to add another building. So that's all things that go into it. So how do I find the actual cost? So the first thing we want to do is, what is the actual cost of the 201st item? Well, I can go ahead and find the cost of 201 items altogether. If I find C of 201, that gives me the total cost of 201 items. What I'm going to do is I'm going to go ahead and put that in my calculator. And what I would highly suggest that you do is go to your y equals. Clear anything in there that is in there by chance. Why is it not clearing? Oh, there. Because I wasn't up there. So we're going to go ahead and type that in. X to the third minus 100th x squared plus 40x plus 5,000. And then what I'm going to do is I'm going to go to my table. If you recall, if you do your table setup, make sure your independent variable is on ask. That's going to allow us to use our table a little easier. If I type in 201, that gives me 10,620. Now, it's probably not going to be exactly that. What I would suggest that you do is to go over to that y value and see exactly what that value is going to be. So if you look, we actually have 10,619 and 98 cents, which is going to be somewhat of importance to us. Well, if I have the cost of 201 items, how do I find the cost of the 201st item? So what I need to do is also go ahead and find C of 200. Since I've already got my equation in, I can just go ahead and type in my 200. Come over here and we get a clean 10,600. So to find the 201st item, we would take the 201 items, subtract off 200 items. So C of 201 minus C of 200 is going to give me $19.98. And that's going to be the cost of that 201st item. Now what I'd like to do is to kind of bring in our calculus. So if we find C prime of 200, we can first do that by finding C prime of x. And C prime of x is going to give us, well, we have our nice power rules there, don't we? So 3 10,000ths x squared minus 1600ths x plus 40. So now I can go ahead and take and plug in my 200 into that. So again, we could go to our y equals, or you could type it in. I'm going to go ahead and clear this out. 0. Plus our 40. Go to our table. We're going to type in our 200, which we already had it there, I guess. So we should see, yay, C prime of 200 is 20. So what do we notice about the derivative at 200 versus the actual cost of 201st item? We see that these two numbers are extremely close to each other. We're within 2 pennies, 2 cents of that cost. So the question is, what do we notice between the actual cost and the C prime of 200? It's going to be very close. They are close. And we say that they're close enough to say that they are going to be the same. So what does that mean for us? Well, if I find C prime of 200, that's going to give us the cost of the 201st item. So C prime of 200 equals the actual cost of 201st item. So if I want to find the actual cost of maybe the 3022nd item, I can find the C prime of 3021. So I always, whatever I want to find the actual cost of, subtract 1, find the derivative of that, and it's going to give me that actual cost. So another definition for marginal is going to be derivative. So whenever you see the word marginal in your mind, hopefully it's going to recall derivative. Next thing I want to talk about today is the average cost. And how do we find average cost of producing a number of items? Well, in order to find the average cost, we would add up all of the cost for that, and then we would divide by the number of units that we have. So how do I find all of the cost? I would find my C of x. And then I would divide by the number of units. So in this case, I had n. If we have x, doesn't matter what variable we're working with. So I would take C of x divided by x. We denote this as C bar of x. So there's going to be a line above that C. And if you've had stats, you probably have seen that already. If not, here's a little introduction to that. So we have C bar of x is going to give us what we're looking for the average cost. So can we find the average cost of 200? Here's our cost function, which looks familiar to us, hopefully, there. It's one that we just had before. So the first thing we're going to do is find C bar of x. So we're going to take our cost function and we're going to divide by x. And I know you probably can do that pretty easily, but I'm going to go ahead and show that out. And I'm going to go ahead and simplify this. So we have 1 10,000th x squared minus 800th x plus 40 plus, since we're going to find the derivative, nope, I didn't find the derivative. I just found C bar, sorry. So we're going to find 5,000 over x. So now we can find C bar of 200. So this is going to give us the average cost of 200 items. I'm going to go back to my y equals. I'm going to go ahead and clear that out. We have 10,000ths x squared minus 800th x plus 40 plus 5,000 divided by x. Again, we're going to go to my table, my 200. So the average cost of producing 200 items is $53 per unit. So here, can we find the marginal average cost? So C bar prime of x. So the first thing we have to do is find the average cost, which up here we already did, and then we're going to find the derivative of that. So since I've already found it, I'm not going to go ahead and do that again. I'm going to go ahead and find C bar prime, which is going to be my derivative. So I have 2,000ths x minus 800ths. So derivative of my 800ths x is x. Derivative of 40 is 0. And then derivative of 5,000x, I can bring my 5,000, bring my x to the top. So I get negative 5,000, x to the negative second. Take that back down to the bottom. So I get negative 5,000 over x squared. So I can find C bar prime of 200. So I can go ahead and plug that in. In here, I'm just going to go and put it on my main screen, I suppose, since I'm about done with it. Times for 200 minus 800ths minus my 5,000 divided by 200 squared. 200. 200. My fingers aren't working today. 200 squared. So that gives me negative 0.165. So what does that mean for us? I'm always going to ask you to interpret your results there. So the average cost when we're producing 200 items, the average cost is decreasing by negative 16.5 cents per unit, or that's decreasing by 16.5 cents per unit in this case. So that gives you kind of an idea of what we're going to be looking at and how our derivatives, our calculus is going to play in with our economics. So again, just to recap, I don't think I explained that very well over here. To find the actual cost, or the relationship between the actual cost and the marginal cost, is going to be that they're very close to each other. And if we can find, if we're looking for the cost of the 1,002nd item, then that's going to equal C prime of 1,001. So C of 1,002 is going to be very close to the C prime of 1,001. So if you have any questions, join us Zoom and we can go over it and talk about it and enjoy some of the marginal economics, and we'll see you later. Good luck.